Yes, good morning, everyone. Can you all hear me? My voice is audible, right? Yes, those who are online, just write down this question. So today we're going to solve the problems on the velocity to find out the velocity of flow of sieve. So velocity of flow we are going to find out for the sieve. So for that, write down this problem for now. I want everyone to have a notebook and a pen with you, and also a calculator. A pen, calculator, and a notebook with you. And I want you all to write down this problem. So your exams will be on from 15th onward, it will start. So 15th, I think first exam itself, it is there for municipal industrial wastewater, I think so. So these problems will be there for the exam problems. So there will be two types of thing, right? One was just like how you had for last time. First one was MCQ. MCQ will be completely theory, and the descriptive type answers will be of problems from the first module as well second module. Both the modules are there. First and second module both are there for the exam. First and second module both are there for the exam, and problems will be there from first as well as second module. Both problems will be there. In descriptive type, problems will be there. So be ready with that. And also Strater-Phillips formula is there. The Strater-Phillips formula equation we are using in solving problem. So only that problem we will be avoiding that problem because it will take a little more time for us to explain that problem. So that Strater-Phillips formula will be problems will be not there for the exam, Strater-Phillips. But finding out the velocity using Manning's formula and other problems will be there. The small problems will be there, but the bigger problem, there's larger problem, that is Manning's formula, sorry, Strater-Phillips formula that you have to use will not be there for the exam. Okay, so I hope you have written this thing. The question given here is, so I had discussed about the formulas in our first class for the module 2. First class, I have discussed a slide in which all the formulas were shown. What was the Manning's formula? All those things were discussed in the first class of the module 2. So same formulas that we are going to utilize in this problem. So the question given to us is, design a sieve to serve a population of 3,600, sorry, that 36,000 population, to serve a population of 36,000. The daily per capita water supply allowance is 135 liters. That is 135 liters per day. Daily, it's given, the word given here is daily per capita water. Daily means per day, every day. So 135 liters per day, of which 80%, that is water supply is 80%, of which the 80% is taken as the sieve. 80% of the water supply is taken as the sieve. So the factor we are multiplying is 0.8. Find its way into the sieve. The slope available for the sieve is 1 in 625. 1 in 625 is the slope given to us. So 1 by 625 is the slope. And the sieve should be designed to carry 4 times the dry weather flow. DWF, that is dry weather flow. The sewer should be designed to carry 4 times the dry weather flow. That means the sewer, the total discharge from the sewer will be 4 times the dry weather flow. That is 4 multiplied by the dry weather flow. When it is running full, what would be the velocity of the flow? Okay, when it is running full, that is the complete drain, if it is running full, what will be its velocity? What velocity of flow, and take n equal to, that is n is nothing but Manning's constant. Manning's constant is n equal to 0.012. Okay, so just a second. I hope you have written the question. Have you all written the question? Please reply. If not written, please reply. I'll just open this and keep it for a little time. Please write it fast. Once you have done with the question, let me know so we can start solving the problem. Please write the question fast. Design a sewer to serve a population of 36,000. The daily per capita water supply or water allowed is 135 liters, of which 80% is find its way to sewer. That is 80% of the total water finds its way to the sewer. The slope available for sewer is 1 in 625. The sewer should be designed to carry 4 times the dry weather flow. Okay, the sewer should be designed to carry 4 times the dry weather flow, and when it is running full, what would be the velocity of the flow? So when it's running full, it will carry 4 times the dry weather flow. And what would be its velocity of flow? Take n equal to 0.12, that is Manning's constant. Yes, done with the question? Done with the question? Have you all done with the question? Reply yes or no. Okay. Okay, so we'll start with the solution then. So for us, given population is given. Population, let us take P equal to how much? It is given 36,000. Okay. Rate of water supply. Rate of water supply. I'm writing in short, rate of water supply is 135. It's 135, right? 135 liters per day, right? Rate of water supply is 135 liters per day. Then percentage in sewer, that means how much percentage of water is coming from the water supply is transmitted into sewer line. That is 80%. That means the factor we are taking it as factor equal to 80 percentage. 80% is equal to 0.8. Right? Then the slope is given. Slope equal to how much? 1 in 625. That is 1 in 625 is 1 by 625 is the slope. That is slope of the sewer line that is laid. The slope, this is the sewer line, just imagine. So the slope is given is 1 in, this is 1, this is 625. The sewer line, somewhat it lays like this. It's not in a proper horizontal plane. It will be almost like a little bit slanted. So the slope will be 1 in 625. That is 625 by 1. That is how the sewer is going to be laid. Okay. Then total discharge. So total discharge will be, since it's a full flow, the full, when the, this is the cross section. Just imagine this is I'm cutting this place. This is a cross section. So normally the dry weather flow will be the dry weather flow given. It's not given. So dry weather flow, 4 times the dry weather flow will give you the complete full discharge. That means the complete circle, this complete cross section is filled with the sewer water. If it is completely filled, then it is 4 times dry weather flow. 4 times the dry weather flow. That means dry weather flow will be almost 1/4 of the sewer. When the sewer is running 1/4, that is the actual dry weather flow. But when it is completely filled, it will be 4 times the dry weather flow. So the total discharge, that means complete discharge, will be a total discharge when the total discharge when the sewer is running full is equal to 4 times dWF, that is dry weather flow. That means total discharge when the sewer is running full, then it is 4 times the dry weather flow. And last thing that is given is Manning's constant, that is N is given equal to 0.1012. That is a Manning's constant. So these many things are given to us. Yes, have you written this? Okay, so let us see how to solve the problem. So you have to find out first what dry weather flow we have to find out. So what is the formula for finding out dry weather flow? You all remember, right? Previous time on the previous first module problems that we have solved was on dry weather flow. You remember, right? Dry weather flow problems that we have solved. So what was the dry weather? How to calculate dry weather flow? That is population into rate of water supply multiplied by factor, right? Factor is equal to how much? 36,000 multiplied by 135 liters per day multiplied by factor 0.8. Since population and factor doesn't have unit, the unit what we'll get will be in liters per day. So how much it is? 3, 8, 8, 8, 0, 0, 0 liters per day. Yes, liters per day. Now we have to convert this into meter cube per second. So convert it and tell me the answer. This one all we have done in the previous class. So tell me the answer first. What will be the dry weather flow in meter per second? So meter cube per second. For liters to meter cube, we have to convert. It should be divided by days to seconds. We are going to multiply the days. So everything will be at the denominator itself. So tell me the answer first. You can use the chat to tell me the answer. We have done this in the first module. Yes, what is the answer? It's not very difficult problem. It's very simple. Difficult problems are yet to come. There are many difficult problems which are there in the second module itself. If you are not able to understand this simple problem, it will be very difficult for you to understand the big problems. Zero point 0.045 exactly 0.045 meter cube per second. Okay, so this is the dry weather flow. But for total discharge or Q is equal to how much? Total discharge Q is equal to how much? 4 times dry weather flow. It is 4 times 0.45. 4 multiplied by 0.045 will be equal to 0.18 meter cube per second. Right? So this is the maximum Q. That is when the maximum Q max we can write. Q max, that is the total discharge. Total discharge, or when the flow in the circular section, when the flow is in the when the flow in the circular section or in the pipeline will be completely full, or the maximum discharge. When it is that is 4 times the dry weather flow, that is 0.18 meter cube per second. Now, what is the Manning's formula for us given? Manning's formula is V equal to 1 by N multiplied by R to the power 2 by 3 multiplied by S to the power 1 by 2. So this is the formula for Manning's formula. This is the Manning's formula for finding out the velocity. V equal to 1 by N multiplied by R to the power 2 by 3 multiplied by S to the power 1 by 2. Where R is hydraulic radius, the hydraulic radius is given as R. Okay. S is the slope. N is the Manning's constant. Okay. Okay. Just write down this formula. V equal to 1 by N multiplied by R to the power 2 by 3 multiplied by S to the power 1 by 2. Okay, just write down this formula. This is the Manning's formula. Manning's formula. Okay. So here we know what and all values we know. We know N, that is Manning's constant, is given in the question. Slope is given in the question. Only the hydraulic radius that we have to find out. So hydraulic radius, find out hydraulic radius. The R formula is R equal to total area of the area of this cross section, the area of the cross section of the sieve, area of cross section of the sieve, total area divided by the perimeter P. Let us take P as perimeter. So if you're taking here P as perimeter, that time here we should take population P or something. P OP population or something you can write down. Because P, again we are taking same denotation, like what we are denoting as P is should not be denoted again something else. So P is the perimeter, A is the area. Perimeter of the cross section, area of the cross section of the sieve. So what this one's area as well as the perimeter should be known to find out the hydraulic radius. So hydraulic radius is R equal to area of the circle, how much it is. We'll take in terms of diameter D. In terms of D we'll take. So area is equal to how much? Pi D square by 4. So this is the area formula divided by perimeter. Perimeter of the circle is 2 pi r, right? 2 pi r is the circumference or the perimeter. Perimeter of what? Perimeter of the circular cross section till which the water is covering. So it is covering. So it is complete discharge is taking place. So the water covering the perimeter will be complete circle's circumference. So that will be how much? 2 pi r. 2 pi r is pi d, right? Pi d. This is the perimeter and this is the area. Area by perimeter. So R equal to pi d get cancelled. Pi d gets cancelled. So R is equal to d by 4. R equal to d by 4. Yes, R equal to d by 4. Now, the formula is, Manning's formula is, find out the velocity V equal to 1 by N. N's value is how much? 0.01 2, right? 0.012 or 0.013. 12 exactly. N equal to 0.012, 0.012 multiplied by R. What is the value of R? It is D by 4. D by 4 to the power whole power 2 by 3. So never get confused. When you write R to the power 2 by 3, that means complete D by 4 to the power 2 by 3, not just D to the power 2 by 3 by 4. It's complete D by 4 to the power 2 by 3 multiplied by slope is how much? 1 by 625, right? 1 in 625. So slope is 1 in 625. Yes. Slope is 1 in 625 to the power 1 by 2. So V value is V equal to how much? Tell me. V is equal to how much to the power? How much into D to the power 2 by 3? Some number will get into D to the power 2 by 3. Tell me the answer. You have to tell me now. Calculate it fast. 1 by 0.012 into D to the power 2 by 3 divided by 4 to the power 2 by 3. 4 to the power 2 by 3 into 1 by 625 to the power 1 by 2. How much is the value of V? V equal to some number into D to the power 2 by 3. Tell me. Let's find out and tell me the answer fast. I hope you are solving this. Yes, how much is the answer? One divided by 0.012 into D to the power 2 by 3 divided by 4 to the power 2 by 3 into 1 by 625 to the power 1 by 2. So answer is 1.323. That is 1.323. We can write down 1.32 or 323 into 2 to the power into D into 2 to the power D to the power 2 by 3. So this is the velocity that we got. Okay. Now you know what is discharge. The discharge is in meter cube per second, and velocity is in what units? Meter per second is the velocity, right? So what is the discharge? Discharge formula is Q is equal to how much? In meter cube per second, and velocity is in meter per second. So what we are multiplying along with the velocity? We are multiplying meter square. So what is meter square? It is the area. We have to multiply velocity with the area to get discharge. Velocity with area to get the discharge. Okay. So let us find out the let us note down the formula. What was the discharge? How much was the discharge? Total discharge. Answer was the given here somewhere. Point when it is maximum complete. It is 0.18 meter cube per second. So maximum discharge was 0.18 meter cube per second is equal to velocity is how much? 1.32 D to the power 2 by 3. Right? This is the velocity V. Into area is how much? Area is pi D square by 4. D square by 4. So find out D value. How much? How much will be the diameter of the circular cross section? Let's find out and tell me. Find out and tell me the answer of D. How much will be the diameter of the circular cross section? Yes, I want everyone to try this problem fast. Find out the value of D. Yes, so what is the value of D? Tell me. 0.18 multiplied by 4 divided by 1.32 divided by 3.14, that is a pi value. And that one's cube root, 3 by 4th root. Right? Zero point 518 or 52 you can write 0.518 or 0.52 you can write down meters. 0.518 meters, it will be in meters, right? Then the velocity is equal to 1.32 into 0.518 to the power 2 by 3. So find out the velocity. This we are substituting in the above formula. This formula we are substituting it to find out the velocity. We know the diameter of the circular cross section of sieve. So find out the velocity. Velocity is equal to how much? Velocity is equal to 0.85 meter per second. So the question was, what was the question? Find out what would be the velocity of flow when the sewer line is running full. So when the sewer line is running full, that is at a maximum Q of 0.18, the velocity will be is equal to 0.85. You have to write down the statement here. When the sewer line is running full, the velocity of the flow is equal to 0.85 meter per second. 0.8 meter per second will be the velocity, and the diameter of the sewer line will be 0.52 or 518, 0.518 meters. Yes, are you clear with this problem? Are you clear with this problem, everyone? So if you understand the concept how the pipeline is laid, you can easily solve the problem. So there are total number of people residing in an area is how much? 36,000 people are there. And the rate of water supply at which the water is coming to each and every house, the rate of water supply will be 135 liters per day. The 80% of water which is supplied will be passed through the sewer line. So 80% is only going through the sewer line. That is 0.8%, 0.8 factor. And the slope for the sewer will be provided in the slope of 1 in 625. And the total discharge will be equal to 4 times the dry weather flow. Whatever will be the dry weather flow, when it is full discharge, it will be 4 times dry weather flow when it is completely discharged. Okay, and Manning's constant 0.012 is given. So we have to find out the velocity at the end. Is all of you done with the problem? Is everyone done with the problem? Please reply. Have you written down this problem? So write down one more problem. So I want you to solve this by your own. Write down this problem. Determine the size of an outfall sewer intended to carry the sewage flow of 650 liters per second. Okay, the sewage flow is given as 650 liters per second. If the average slope of the line is 1 in 1000 and the sewage is flowing half full, assume n equal to 0.015 in Manning's formula. So in this question, for us directly, the discharge value is given. So discharge value is 650 liters per second. So discharge value of a sewer is 650 liters per second is the discharge. Okay. And the slope is given 1 by 1000. And assuming and the sewage is flowing half full. So when it is half full, whatever will be the area will be divided by 2. Okay. Whatever will be the area will be divided by 2. And the Manning's constant is given as 0.15. So you have to use the formula that is given as Manning's formula, V is equal to 1 by n to the power r into r to the power 2 by 3 into s to the power 1 by 2. Only the change here will be the area what you are taking. Area what you are taking will be a by 2 when you are talking about the discharge. That is, when finding out the velocity, you are taking complete area itself. That is area by p, that is d by 4. R is equal to d by 4 we are taking. Only when you substitute in q is equal to a by f, sorry, a into v. Q is equal to a into v. In that formula, the a value will be a by 2 because it is partially full. The a value will be a by 2. So whatever the area that you will be taking is equal to pi d square by 4, no? So that will become pi d square by 8 because a by 2 you are taking. Other than that, velocity, all things will be same. You have to find out the velocity at the end. So for your reference, write down this problem first. And I'll make you what are the things that is given. I'll make you write what are the things that is given. Write down the problem first. Yes, please write down the problem first. Determine the size of an outfall sewer intended to carry a sewage flow of 650 liter per second. So liter per second convert into meter cube per second. So 650 liters per second. So first thing that is given is Q is given. Q is 650 liters per second. That is 0.65 meter cube per second divided by 1000. If the average slope of the line is given as 1 by 1000, the sewage is flowing half full. When it is half full, that is when it is half full, the value is given as 650 liters per second. When it is half full, for half full, the value is given as 650 liters per second. So Q partially or Q half full is 0.65. Q half full is equal to 0.65 meter cube per second. Okay, and slope is given 1 in 1000. Assuming Manning's constant as 0.015. Okay, so what we have to find out first? We have to find out the velocity, but we don't know the dia. So in that we'll obtain the first one, we'll obtain the dia formula, that is 1 by n into r to the power so we'll get the formula as 1 by n into r to the power 2 by 3 into s to the power 1 by 2. So r is equal to d by 4, that we know, area by perimeter. So that we are considering completely itself. Area will be area itself, complete area for finding out r. That is d by 4 will get. That d by 4 you have to substitute here, and you have to get an equation b equal to something into d to the power 2 by 3 you'll get. So now what you will get, what value you will get it here, that you have to substitute in q half full equal to v into area half area, that is q into something d to the power 2 by 3 into area half means pi d square by 4 divided by 2, half of the area, half, this is the area, half of the area, that is q into something d to the power 2 by 3 q half flow into pi d to the power 2 divided by 8. So you have to find out d. You know the value of q, that is 0.65. That is 650 liters per second. We are converting into meter cube per second, 65. Yes, is equal to something d to the power 2 by 3 into pi d to the power 2 divided by 8. So you have to find out the d. Then find out the v. So we get the velocity. Yes, are you clear with this? Have you all written that problem? Have you all written this problem? Please reply. The time is going to end fast. Yes, so we'll end today's session here itself. So write down this problem and solve it. You have to solve this. Okay, Pavitra, are you there? Just take the attendance fast. The time is ending fast.
Okay, sir.
Pavitra, are you there? Just take the attendance. If you have any doubt, you can ask me. I'll be sharing you those problems and all once we are finished with the complete problems. For internals, what and all are required, that much problems I'll be sharing you. Okay. So start preparing now itself. Start studying. Okay. Thank you, everyone. We'll end the session for today here itself. Thank you.